your midterm. It's very similar to your review. It's 50 questions, 40 of them are multiple choice, 10 of them are short answer. We're just going to get right into this. So the first 4 questions from your midterm review tell you to state whether the equation defines y as a function of x. If you remember from this section, if y is raised to an even power, or it's in absolute value bars, or it's in the denominator of a fraction, it's not a function. So for number 1, you have f of x is equal to x cubed plus 5x minus 9. You don't have a y raised to an even power there. It's literally f of x and y are the same thing. So we're good. This one is a function. For number 2, you have f of x is equal to the absolute value of 3y plus 8x squared minus 2. Because that y is inside the absolute value bars there, it is not a function. For number 3, that should be 3, not 2. You have f of x is equal to the absolute value of 3x plus 8 plus 8y. The 8y, that y is not inside the absolute value bars. It's not raised to an even power. It's not in the denominator of a fraction. So this one is a function.
So if the y was raised to an even number, it would be not a function?
Yeah, so like if you look at number 4, you have f of x is equal to 3y to the 4th power plus 9x. That y is raised to an even power, so this one is not a function. The next section that we look at, we're stating whether the function is odd, even, or neither. Remember, with these, you're going to plug in 2, and you're also going to plug in negative 2. If you get the same answer for both, they're even. If they're opposites, they're odd. And if they're 2 totally different numbers, it's neither. So for number 5, we have f of x is equal to x to the 5th power plus plus x. So if we do f of negative 2 to start, that's going to give us negative 2 to the 5th power plus negative 2. That negative 2 to the 5th power gives us negative 32 plus negative 2, which is negative 4, or negative 34. We're also going to do the same thing with positive 2. So this is going to give us 2 to the 5th power plus 2. 2 to the 5th power is 32 plus 2 gives us that f of 2 is positive 34. These are opposites of one another, so this function is odd. For number 6, we're going to do the same thing. We're going to plug in the negative 2. We're going to plug in the 2. We're given f of x is equal to 1 minus x to the 4th power. So if we do f of negative 2, this is 1 minus negative 2 to the 4th power. The negative 2 to the 4th power is 16. So that gives us 1 minus 16, which is negative 15. If we also do f of 2, this is going to give us 1 minus 2 to the 4th power. The 2 to the 4th power is 16, so that's 1 minus 16, which is f of 2 is equal to negative 15. These two numbers are the same exact number, so this function is even. For number 7, you have f of x is equal to 2x minus x squared. So if we do f of negative 2, it's going to give us 2 times negative 2 minus negative 2 squared. The 2 times negative 2 is negative 4, and the negative 2 squared is 4. So it's negative 4 minus 4, which gives us f of negative 2 is equal to negative 8. If we also do f of 2, that's going to be 2 times 2 minus 2 squared. The 2 times 2 is 4, minus 2 squared is 4. 4 minus 4 gives us f of 2 is equal to 0. These two numbers are neither the same nor are they opposites. So this one is neither. For our next set of questions, we are stating the end behavior using arrow notation or end behavior notation. With these, if you want, you can just tell me falling left, falling right also. And then from there, give the arrow notation. Your answer choices on your midterm are with the arrow notation or the end behavior notation. So for number 8, you have f of x is equal to the opposite of x to the 5th power plus 3x. Our power here is that 5. It is odd, but there's a negative in front of it. So it's going to open to the left, up, and then down to the right. So this is rising left, falling right. From here, we can tell that as x goes to negative infinity, your f of x goes to positive infinity. And as x goes to positive infinity, your f of x goes to negative infinity. So again, your answer choices on your midterm will be in this form. For number 9, you have g of x is equal to x to the 4th power plus 9x squared. Your highest power here is that 4. There is no negative in front of that x to the 4th power, so the graph of this would look like this u that opens upwards. So if it opens up, it's going up as it goes is to the left, as well as to the right. So as x goes to negative infinity, your g of x goes to positive infinity. And as x goes to positive infinity, your g of x goes to positive infinity as well. For number 10, you have h of x is equal to 7x cubed minus 1. Your power on this is 3. There is no negative in front of it, so it opens up and to the right, down and to the left. So this is falling left, rise right. So as x goes to negative infinity, your h of x goes to negative infinity. And as your x goes to positive infinity, your h of x also goes to positive infinity. For 11, you have k of x is equal to x squared minus 3x. The power on this x squared is the 2. It's even. There's no negative in front of it, so it opens up. So this is rising left, rising right. So as x goes to negative infinity, your k of x goes to positive infinity. And as x goes to positive infinity, your k of x goes to positive infinity. If we look at the next set of questions, we're seeing the increasing values, the decreasing values, and constant values from the given graphs. For number 12, remember when you're looking at these, you're looking at the x values, where the line goes up from left to right, or the line stays flat from left to right, or the line goes down from left to right. So it's the x values that you're focusing on. If you look here, on this graph for number 12, you're going up from left to right here, as well as here. You are also going up here. So the x values that are being covered from the lowest to the positive, or sorry, lowest to highest for increasing. Oops. You are going from -8, including the -8, up to -2. Then you are going from 0 to 2. And then you're going from 2 to 10. This should be negative 10 also, not positive, or not negative 8. So let's change this to be negative 8, or negative 10, I'm sorry, from negative 8. From here, think about your decreasing value, so where the line goes down. Your line only goes down in this section here, so you're decreasing is just from negative 2 to 0. And then your constant, you don't have any part where that line is flat horizontally, so your constant is none. For number 13, your increasing values for this are from here to here, as well as here to here. So we are going from 5, 6, 7, 8, negative 8 to 3. And this negative 8 should, it includes, so it should have a bracket on it. Then it also goes up from 0 to positive 2. So the 0 is included, bracket, positive 2 is included, bracket.
Is that a negative 3?
Yes, that is a negative 3. Thank you. For your decreasing, it goes down from here to here. So that's from negative 3, including the negative 3, to 0, including the 0. And that's it. Lastly, you have your constant, which is from this point here to this point here. So that's from 2, including the 2, to positive 12, including the 12. For 14, we have a lot of different lines here. If we look at those increasing values first, you are increasing from 1 to, or sorry, from negative 1 to 1. And it is including the negative 1, does not include the 1, so the 1 will get parentheses on it. Then for your decreasing, from left to right, you're going down from negative 11 to negative 5. Or sorry, negative 10 to negative 5, not including the negative 5, as well as from 1 to 10, including the 1 and the 10.
Wait, I have a question.
Mm-hmm.
For increasing, why is it negative 1, 1?
It's negative 1 and 1 for increasing, yes. Because your line from left to right as it goes up is just going up here. No other line goes up from left to right. Okay, so yeah, this should be 3, not 1. Sorry, thank you. Okay, so then from here, we look at our constant. Our constant we have goes from that negative 5 up to negative 1. And that negative 1 has an open circle, that negative 5 has a closed circle. So we're going to do bracket, negative 5, comma, negative 1, parentheses. For number 15, we are going up, so we're increasing from 0 to 1. Oops. We're including both of them as well, so brackets on both. We are also going up from 2 to 4. So that's with a union from 2, not including the 2, to 4, including the 4. Again, if that had an arrow on the actual line, it would go to positive infinity up. So it would also go to the positive infinity to your x to the side, which then that 4 would become an infinity. But it does not have an arrow on there, so we're not going to include that. Next, you will look at your decreasing. So going down from left to right happens here. So that's from -2 to 0, including the -2, including the 0, so brackets on both. Nowhere else does the line go down from left to right. Lastly, you have your constant, which is just here. So that's from 1 to 2. So parentheses on the 1 since it doesn't include, and then the bracket on the 2 since it does. So yeah, this should also be a 3, not a 1.
I guess on the graph it kind of looks like a 1.
Maybe. I don't know why I kept thinking that it was a 1. I don't know. For your next set of questions, you are just multiplying. So follow your rules, FOIL if you want to, totally up to you. So for 16, you have 3x plus 2 to the third power. This is the same exact thing as saying 3x plus 2 times 3x plus 2 squared. That 3x plus 2 squared, if you use your a squared plus 2 times a times b plus b squared, it's going to give you 3x plus 2 times 9x squared plus 12x plus 4. From here, distribute in the 3x, distribute the 2, combine like terms. So 3x times 9x squared is 27x cubed. The 3x times 12x is 36x squared. And then 3x times 4 is 12x. From here, do the same with the 2, distribute it in. So 2 times 9x squared is 18x squared. Then 2 times 12x is 24x. And 2 times 4 is 8. If we combine like terms here, that 27x cubed drops down. You have 36x squared plus 18x squared. The 6 plus 8 is 14. Carry the 1. The 3 plus 1 is 5. Move on to the x values. So 12x plus 24x is 36x, and then the 8 drops down. So you have 27x cubed plus 54x squared plus 36x plus 8. For 17, you have x plus 5 to the fourth power. So this is the same thing like saying x squared plus 10x plus 25 times x squared plus 10x plus 25. So you're just going to distribute in. So x squared times x squared is x to the fourth power. Then x squared times 10x is 10x cubed. X squared times 25 is 25x squared. And 10x times x squared is 10x cubed. 10x times 10x is 100x squared. 10x times 25 is 250x. Then the 25. The 25 times x squared is 25x squared. Then 25 times 10 is 250x. And then the 25 times 25, let's do this here. I think it's 625, but we're going to double check. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12. Add on your 0. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. Yep, 625. Oops. Okay. So from here, we're just going to add. We're going to have x to the fourth power plus 20x cubed plus 150x squared plus 500x plus 625. For number 18, you have 4x minus 1 squared. For this one, your A is the 4x, your B is the 1. There's a negative between the two, so we're going to use a squared minus 2 times a times b plus b squared. You can also just expand this and FOIL it out. It's whatever you're comfortable with. So if we use this method, we're going to have the 4x squared, which is 16x squared. Negative 2 times 4x is 8x. Negative 8x times 1 is negative 8x. And then 1 squared is 1. We are going to change number 19 to be 5x plus 6 squared. So with this one, your A is the 5x, your B is the 6. If there's addition there, you're going to use A squared plus 2 times A times B plus B squared. So your A squared, the 5x squared, is 25x squared. 2 times 5x is 10x times 6 is 60x. And then 6 squared is 36. So that's 25x squared plus 60x plus 36.
And we can use that when it's anything that's squared.
Yeah, if it's a binomial squared, you can use this method, or the one for number 18, depending on the sign in between the two. You don't have to use that. If you, like I said, rather FOIL it out, expand it, then FOIL it, you're going to get the same thing if you multiply correctly and then combine your like terms correctly. Oh, 18 and 4 numbers 18, or I thought it was 18. Is there not over there? So 20 through 22, you're finding the inverse of each function. Remember with these, you're going to change your f of x, your g of x, or your h of x in these cases to be y. Then you're going to switch x and y and then resolve for y. So if we look at number 20, you have f of x is equal to x squared plus 3. If we change this f of x to be y is equal to x squared plus 3, and then we switch x and y, this is going to give us x is equal to y squared plus 3. And now all we got to do is solve for y, and then rewrite our inverse as, in this case, f to the negative 1 of x is equal to. So we're going to start this, or finish this off by subtracting 3 from each side. This gives us y squared is equal to x minus 3. Take the square root of both sides. You're going to have y is equal to the square root of x minus 3. And that goes plus or minus in front of it. So we start with f of x. When we write our answer, that's f to the negative 1 of x is equal to plus or minus the square root of x minus 3. For 21, you have g of x is equal to 3x cubed minus 6. We're going to change that g of x to be y. So y is equal to 3x cubed minus 6. Then we're going to switch x and y. So it's going to be x is equal to 3y cubed minus 6. Move your 6 over, add it to both sides. This gives us 3y cubed is equal to x plus 6. Divide each side by the 3. This leaves you with y cubed is equal to x plus 6 over 3. Then take the cube root of both sides. So you have y is equal to the cube root of x plus 6 over 3. Your function started as of g of x. So your inverse is g to the negative 1 of x is equal to the cube root of x plus 6 over 3. For number 22, you have h of x is equal to 1/2 x plus 7. So that h of x becomes y. Then we switch x and y, so where we have x is equal to 1/2 y plus 7. We're going to subtract over that 7. And this leaves us with 1/2 y is equal to x minus 7. Then we multiply each side by 2. Cancels out the 1/2. We have y is equal to 2x minus 14 because we distributed the 2 in. We started our function with h of x, so our inverse is h to the negative 1 of x is equal to 2x minus 14. for 23 through 25, we're simplifying each expression and writing our answer in the form of a plus bi. For 23, you have 5 minus 3i plus negative 4 minus 7i. There's addition between these two sets of parentheses, so we can just rewrite it as 5 minus 3i plus negative 4 or minus 4 minus 7i. Your like terms here, if we're going in the form of a plus bi, you would combine those constants first. So 5 minus 4 is 1, and then the negative 3i minus 7i is negative 10i. So it's just 1 minus 10i. For 23, you have negative 12 plus 8i minus 7 plus 4i. So since there's addition between these two sets of parentheses, we are going to distribute that negative into the second set of parentheses. So this will give us negative 12 plus 8i minus 7 minus 4i. So now just combine your like terms like we did on the one before this. You have your negative 12 and your negative 7 that are like terms, which combine to give you negative 19. Then you have 8i minus 4i, which is positive 4i. So it's just negative 19 plus 4i. For 24, we have 6 plus 5i times 2 minus 3i. We're going to FOIL this. So we're just going to take the 6, distribute it into the second set of parentheses, then do the 5i, distribute it into the second set of parentheses. So if we do 6 times 2, it gives us 12. The 6 times negative 3i is negative 18i. The 5i times 2 is positive 10i. And then 5i times negative 3i is negative 15i squared. So if we look here, we have two terms that are like terms that we can combine. That gives us 12 minus 8i minus 15i squared. That I squared is also negative 1. So I squared is equal to negative 1. If we change this up to be 12 minus 8i minus 15 times negative 1, this ends up becoming 12 minus 8i minus 15 times negative 1 is a positive 15. So from here, combine your like terms. The 12 and the 15 are like terms, which give us 27 minus 8i. That is in the form of a plus bi, so that is your answer. For 25, we have 2 minus 3i over 1 minus 2i. We do have to rationalize this fraction. By doing so, we are going to take the conjugate of our denominator and multiply by the top and the bottom of this fraction. Remember, the conjugate of your denominator here is just going to be the same terms, but the opposite sign between them. So I'm going to start by putting parentheses around both my numerator and my denominator. Then I'm going to multiply my denominator by its conjugate, so 1 plus 2i. What I do to the bottom, I have to do the top, so I multiply the top by 1 plus 2i as well. And then we're just going to FOIL these out. So 2 times 1 is 2. 2 times 2i is 4i. Negative 3i times 1 is negative 3i. Negative 3i times 2i is negative 6i squared. On the bottom, we have a difference of squares, so it's just 1 squared minus 2i to the second power. Up top, combine your like terms. That negative, or that I squared becomes negative 1. So multiply that by the negative 6 as well. This is going to give you 2 minus 7i plus 6 over the 1 squared is 1 minus 2i to the second power is 4i squared. Again, you have that I squared, which is equal to negative 1. So multiply that by the 4. Up top, combine your like terms. The 2 plus the 6 gives us 8 minus 7i over 1 plus 4. That 1 plus 4 is 5. So your final answer is 8 minus 7i all over 5. Our next section, we are finding all real solutions. So remember with these, if you have fractions that have expressions in them, find your least common denominator, multiply the entire expression by that least common denominator, and then simplify from there. That will get rid of your fractions, and you don't have to work with them. So if you look at number 26, you have 1 over x minus 1 plus 1 over x plus 2 is equal to 5/4. your least common denominator here, least common denominator is x minus 1 times x plus 2 times 4. So we're going to multiply whatever we don't have in our least common multiple, or whatever we don't have in our denominator of a fraction that's in that least common denominator by the numerator. So the first one, the 1 over here, let's do it this way instead. We're going to do our least common denominator, which is 4 times x minus 1 times x plus 2 multiplied by 1 over x minus 1. From here, we're going to multiply that least common denominator again, so 4 times x minus 1 times x plus 2 times that fraction, so 1 over x plus 2. And then our 5 over 4 gets multiplied by the same thing, so the 4 times x minus 1 times x plus 2 all over 5, or all multiplied by 5 over 4. So what's the same in your least common denominator and your least common denominator and your actual denominator are going to cancel out. So with the first one, so the one furthest to the left, that x minus 1 on both of these cancel out. So you're literally just doing 1 times 4 times x plus 2. The middle one, you have 4 times x minus 1 times x plus 2, all multiplied by 1 over x plus 2. The x plus 2's are the same, so they cancel. So it's just 1 times 4 times x minus 1. Then your answer, you have 4 times x minus 1 times x plus 2 times 5 over 4. The 4's are the same, so they cancel. So you're going to do 5 times x minus 1 times x plus 2. From here, multiply these out. The 1 times 4 is 4. Distribute the 4 into the parentheses for both of these. And then I would FOIL out the the x minus 1 times x plus 2, and then distribute the 5, or you can distribute the 5 first and then FOIL. It's up to you. So the 4 times x is 4x. The 4 times 2 is 8. Then again, the 4 times x is 4x, and 4 times negative 1 is negative 4. The 5 times x is 5x. The 5 times negative 1 is negative 5. So you're multiplying that by x plus 2. At the same time, I'm going to combine my like terms on the left side. We have 4x plus 4x, which is 8x. Then we have 8 and negative 4, which is 4. If I FOIL this out, the 5x times x is 5x squared. The 5x times 2 is 10x. Negative 5 times x is negative 5x. And negative 5 times 2 is negative 10. This is equal to, not plus this. Where did it go? Oh yeah, it's there. Okay, so we're going to combine our like terms on that right side, and this is going to give us 8x plus 4 is equal to 5x squared minus 5x minus 10. I want to move all my terms over to the same side of my equal sign, so that way this is equal to 0 now. I have an x squared, so I'm going to bring anything on the opposite side of that equal sign of the x squared over to be with the x squared. So that 8x, we're going to subtract from each side. The 4, we're going to subtract from each side. So this gives us 5x squared minus 13x minus 14 is equal to 0. If you try to factor this, the 5 times the 14, the 5 times 4 is 20. That's going to give us negative 70. Look at your factors of negative 70. Do any of them add up to be the negative 13? You have 1 and 70, 2 and 35, 3 does not go into it evenly, 4 does not go into it evenly, 5 goes in 14 times, 6, no, 7, 10 times. None of these are going to give you a negative 13 if they have opposite signs. So you can use your quadratic formula in order to solve for x here. So remember your quadratic formula, x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Your a is the 5, your b is the negative 13, your c is the negative 14. So this is going to give us x is equal to the opposite of b, which is positive 13, plus or minus the square root of negative 13 squared minus 4 times 5 times negative 14 all over 2 times 5. This then simplifies to be 13 plus or minus the square root of 169 plus 4 times 5 is 20 times 14 is 280 all over 10. Add your terms underneath your radical from here. So x is equal to 13 plus or minus the square root of the 9 plus 0 is 9, 6 plus 8 is 14, carry the 1, 2 plus 2 is 4, all over 10. From here, you'd actually simplify if you can. So you would try to find the prime factorization of the 449 to find the square root of it and see if you can simplify that any further. So you cannot take the square root of that 449, so you leave this just like you have it, and this is your answer. From here, we went up to here. For number 27, you have x over x plus 3 is equal to 2 over x minus 3 minus 1 over x squared minus 9. That x squared minus 9 is the same thing as x minus 3 times x plus 3. So your least common denominator from these three fractions is x minus 3 times x plus 3. That first fraction doesn't have the x minus 3 underneath it, so you'll multiply by x minus 3. The second fraction, it doesn't have the x plus 3, so you'll multiply the x plus 3. Denominator cancels out. The third one, that minus 1 over x squared minus 9, your least common denominator is the x squared minus 9, so you don't have to do anything with that one. So you are going to rewrite this as x times x minus 3 is equal to 2 times x plus 3 minus 1. Distribute in the x, distribute in the 2, and then you'll be set from there. So x times x is x squared, x times negative 3 is negative 3x. Put your equal sign down. 2 times x is 2x, and 2 times 3 is 6. From here, again, we have an x squared, so I want to bring everything on the same side as that x squared. So we are going to move over that 2x by subtracting it from each side. We can also combine your like terms with the 6 and then minus 1 to give us x squared minus 5x is equal to 5. We're going to subtract the 5 from each side. You have x squared minus 5x minus 5 is equal to 0. You do not have factors of negative 5 that add up to be negative 5. So from there, you're going to use your quadratic formula again. So that b squared, or negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this is going to give you x is equal to the opposite of b. Your b is the negative 5, so that's 5 plus or minus the square root of negative 5 squared minus 4 times a, which is 1, times c, which is negative 5, all over 2 times a, which is 1. So from here, we just simplify. So we have x is equal to 5 plus or minus the square root of 25 plus 20 all over 2. That 25 plus 20 underneath the radical becomes x is equal to 5 plus or minus the square root of 49 all over 2. 45, not 49. 45 over 2. So from here, that 45 does actually simplify. It is 9 and 5. 9 is 3 and 3. You have two factors that are the same. So this ends up giving you x is equal to 5 plus or minus 3 square root 5 over 2. You don't have any common factors between your 5, your 3, or your 2. So that is your answer. For 28 and 29, you're solving, 28 through 31. Yeah. You're solving in each inequality and writing your answer using interval notation. For 28, you have 2x squared plus x is greater or less than greater than or equal to 1. Remember with these, if it's greater than or equal to, or greater or less than or equal to, and. Okay, so for this one, we're going to move that 1 over, so we're going to subtract it from each side. We have 2x squared plus x minus 1 is greater than or equal to 0. Your a is something other than 1, so multiply your 2 times your negative 1. That gives you negative 2. Your factors of negative 2 that add up to be positive 1 are 2 and negative 1. So this gets rewritten as 2x squared plus 2x minus x minus 1 is greater than or equal to 0. From here, factor by grouping. You're going to factor out a 2x from the first, a negative 1 from the second. So this is 2x times x plus 1 minus 1 times x plus 1 is greater than or equal to 0. You have two sets of parentheses here, the 2x minus 1 and the x plus 1, which is greater than or equal to 0. Set these both greater than or equal to 0 and solve them. So you have 2x minus 1 is greater than or equal to 0, and x plus 1 is greater than or equal to 0. Move your 1 over, add it to both sides. You have 2x is greater than or equal to 1. Then from here, divide each side by the 2. So x is greater than or equal to 1/2. For the x plus 1 is greater than or equal to 0, subtract your 1 from each side, and you just have that x is greater than or equal to negative 1. On your number line, if you were to graph these, you would have a negative 1, you'd have the 1/2. Both of these get closed circles, and we said it's or, greater, or, so your lines would go away from one another. So to put this in interval notation, you're going from negative infinity up to negative 1, including the negative 1, with a union of 1/2, including the 1/2, to positive infinity. Your answer choices for these will be given to you in interval notation, so please make sure that you know how to write it in interval notation. Easiest way, graph them, see where your line goes. From there, write your interval notation. For 29, we have 3x squared minus 3x is less than 2x squared plus 4. I'm going to move that 2x squared over to my 3x squared by subtracting it from each side. I'm also going to subtract the 4 from each side as well, so that way this is less than 0. So this is going to give us x squared minus 3x minus 4 is less than 0. What are your factors of negative 4? That add up to be 3. You have 1, or negative 3. You have 1 and negative 4, which give you negative 3. So this factors out to be x plus 1 times x minus 4 is less than 0. We said earlier that this less than means and, so we got to keep that in mind when we go to graph this once we solve for each of these. So we're going to set both of these equal, or not equal, less than 0. So that's x plus 1 is less than 0, x minus 4 is less than 0. Move your 1 over, subtract it from each side. That's x is less than negative 1. Move your 4 over, add it to both sides, x is less than 4. On your number line, you would find the negative 1, you'd find the 4, open circle on the negative 1, open circle on the 4, since they're just less than, and we said less than and, you would connect those two lines. Which means, for your interval notation, you're going from negative 1 to 4, nothing else. You're not including the negative 1, so parentheses will go on that. You're not including the 4, so parentheses go on that as well. For 30, we have x squared is greater than 3 times x plus 6. First thing we're going to do here is distribute this 3 into the set of parentheses. So this gives us x squared is greater than 3x plus 18. We're going to move the 3x over by subtracting it. We're also going to move the 18 over by subtracting it. So this is going to give us x squared minus 3x minus 18 is greater than 0. You want to find your factors of negative 18 that add up to be negative 3. you have 3 and negative 6. So this factors out to be x plus 3 times x minus 6 is greater than 0. Set these both equal to 0, or not equal to, greater than 0, and solve. So x plus 3 is greater than 0, x minus 6 is greater than 0. Move your 3 over by subtracting it from each side. It gives us x is greater than negative 3. Move your 6 over by adding it to both sides. That's x is greater than 6. We said greater or, so on your number line, you're going to find the negative 3, you're going to find the 6, open circles on both, or is away. So this is going from negative infinity up to negative 3, not including the 3, with a union of 6 to infinity, not including the 6. For 31, you have x squared plus 2x is less than or equal to 3. For this one, we're going to move that 3 over by subtracting it from each side, so that way all of our terms are on the same side. This gives us x squared plus 2x minus 3 is less than or equal to 0. Your factors of negative 3 that add up to positive 2 are 3 and negative 1. So this factors out to be x plus 3 times x minus 1 is less than or equal to 0. We set these both equal or less than or equal to 0. And then we solve. So we're going to move the 3 over by subtracting it from both sides. So x is less than or equal to negative 3. Add your 1 over to both sides. X is less than or equal to 1. So on your number line, that negative 3 is going to have a closed circle. That 1 is going to have a closed circle. This is less than or equal to, so less than and they connect, which means you're going from negative 3 to positive 1, including both of those. So brackets go on both. For question 32, it tells us to use the quadratic formula in order to solve. Remember, your quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to use that in solving these. For 32, we have 4x squared plus 16x is equal to 9. If a term is not on the same side with your x squared and your x, move it over. Everything should be on the same side, and this should be equal to x, or equal to 0, before you even start using your quadratic formula. So the first thing we're going to do is move the 9 over by subtracting it from both sides. This gives us 4x squared plus 16x minus 9 is equal to 0. Your a is 4. Your b is 16. Your c is negative 9. Plug this into your quadratic formula and simplify. So x is equal to the opposite of b, which is 16, plus or minus the square root of 16 squared minus 4 times a, which is 4, times c, which is negative 9, all over 2 times a, so 2 times 4. The opposite of 16 is negative 16. Plus or minus the square root of 16 squared is 256. The negative 4 times negative 9 gives you is giving you positive 144. So this is all going to be over 8. So you add what's underneath that radical, and you get x is equal to negative 16 plus or minus the square root of 256 plus 144 is 400 all over 8. From here, that 400 is 20 times 20, so the square root of it gives you negative 16 plus or minus 20 over 8. This has to be simplified. This is not your answer. Because your radical simplified and you no longer have a radical, you need to separate this into 2 parts or 2 equations and solve them both. So you're going to have x is equal to negative 16 minus 20 over 8, as well as x is equal to negative 16 plus 20 over 8. So this is going to give us x is equal to negative 36 over 8 and x is equal to 4 over 8. So simplify these both. The 36 and the 8 are both divisible by 4. So the negative 36 becomes negative 9. The 8 becomes 2. So this is just negative 9 over 2. And then this one, they're both divisible by 4 as well. So that's 1/2. For 33, you have 6x squared plus 12x plus 7 is equal to 0. All of your terms for this one are on the same side. So your A is 6, B is 12, C is 7. So we have x is equal to the opposite of b, which is negative 12, plus or minus the square root of b squared, so 12 squared, minus 4 times a, which is 6, times c, which is 7, all over 2 times a, so 2 times 6. This is going to simplify to be negative 12, plus or minus the square root of 144, minus the 4 times 6 is 24, or negative 24, times 7 is negative 168, all over 12. So from here, you're going to subtract underneath that radical, and that's going to give you x is equal to negative 12 plus or minus the square root of negative 24 all over 12. That negative underneath the radical has to become a positive. So pull out that negative by representing it with an I in front, and then find the prime factorization of 24. 24 is 4 and 6, 4 is 2 and 2, 6 is 2 and 3. 2 of your 2's pair up, so this becomes x is equal to negative 12 plus or minus 2i square root 6 all over 12. Your negative 12, your 2i, and your 12 are all divisible by 2. So that negative 12 becomes negative 6, the 2i just becomes I, and then the 12 becomes positive 6. Remember, what's under the radical does not get touched. So x is equal to negative 6 plus or minus I square root 6 all over 6. For your next set of questions, you are solving by factoring. Again, just like with your quadratic formula, get everything on the same side of your equal sign, set it equal to 0, and then factor. For 34, you have 12x squared minus 44x is equal to 45. That 45 you got to bring over to the other side. So subtract it from each side to start with. This leaves us with 12x squared minus 44x minus 45 is equal to 0. We do not have a greatest common factor that we can factor out. So we're going to multiply the 12 times the negative 45. That gives us 500 or negative 540. If we divide this or find the factors of this that add up to be 44, you would have 54, which is going to be negative, and positive 10, which gives you the negative 44. So this is going to get rewritten as 12x squared plus 10x minus 54x minus 45 is equal to 0. Since we have 4 terms now, we're going to factor by grouping. The 12x squared and the 10x share a common factor of 2x. The negative 54x and the negative 45 share a common factor of negative 9. So this is going to give us 2x times 6x plus 5 minus 9 times 6x plus 5 is equal to 0. Your 2 sets of parentheses are identical now, so rewrite them once and then form another with a 2x minus 9. From here, set both of these sets of parentheses equal to 0 and solve. So we have 6x plus 5 is equal to 0, and 2x minus 9 is equal to 0. For the 6x plus 5 is equal to 0, move your 5 over by subtracting it from each side. This gives you 6x is equal to negative 5. From here, divide each side by the 6, and you have that x is equal to negative 5/6. So that's one of your solutions. For the 2x minus 9 is equal to 0, move your 9 over, add it to both sides. This gives you 2x is equal to 9. Then divide each side by the 2. So x is 9 over 2. So you have two solutions for this one, the negative 5/6 and the 9 over 2. For 35, we have 6x times x minus 1 is equal to 21 minus x. First thing we got to do here is multiply in that 6x. So this gives us 6x squared minus 6x is equal to 21 minus x. We're going to move the x over by adding it to both sides. We're also moving the 21 over by subtracting it from both sides. So we're going to be left with 6x squared minus 5x minus 21 is equal to 0. You do not have any like factors that you can factor out from here. So multiply your 6 times your negative 21. That gives you negative 126. You want to find your factors of negative 126 that add up to be negative 5. If you do 1 and 126, 2 and 63, 3 and 42, 4 does not go into it evenly, 5 does not, 6 goes in 21 times, 7 does not go into it even, it does, 7 goes in 18 times, 8 does not go in, no, 9 goes in 14 times. So if the 14 is negative and the 9 is positive, that gives you your negative 5 that you're looking for. So this is going to be rewritten as 6x squared plus 9x minus 14x minus 21 is equal to 0. We're going to factor by grouping since we have the 4 terms. Factor out a 3x from the first set, factor out a negative 7 from the second. This gets rewritten as 3x times 2x plus 3 minus 7 times 2x plus 3 is equal to 0. From here, we rewrite as 3x minus 7 times 2x plus 3 is equal to 0, and then we solve both of them. So 3x minus 7 is equal to 0, and 2x plus 3 is equal to 0. Move your 7 over, add it to both sides. You have 3x is equal to 7. Then divide each side by the 3. And you get that x is 7/3. For the 2x plus 3 is equal to 0, subtract your 3 from both sides. You have 2x is equal to negative 3. Then divide each side by the 2. And you have that x is negative 3 over 2. For your next question, you have 3x squared plus 15x plus 18 is equal to 0. For this one, all of your terms are on the same side of your equal sign. It is equal to 0, and you can factor out a greatest common factor, which is 3. So you're going to start this one by factoring out a 3. This is going to leave you with 3 times x squared plus 5x plus 6 is equal to 0. Your factors of positive 6 that add up to be 5 are positive 2 and positive 3. So this factors to be 3 times x plus 2 times x plus 3 is equal to 0. Set every part equal to 0 now and solve. That 3 is equal to 0. It's a false statement. Get rid of it. Don't worry about it. The x plus 2 is equal to 0. Move your 2 over. Subtract it from each side. So x is equal to negative 2. For x plus 3 is equal to 0, subtract your 3 from both sides. You have that x is equal to negative 3. So you just have the two solutions for this one, the negative 2 and the negative 3. For your next set of questions, you're finding the domain from each function. With these, for number 37, you have f of x is equal to 3x squared plus 2x is minus 9. All of your terms are on the same side. You do not have an x in the denominator. You do not have an x under the radical. You do not have an x under the radical in the denominator. So because x does not go in any of those three circumstances, your domain is all real numbers. So your domain would be written in interval notation from negative infinity to positive infinity. So real simple. If x is not in the denominator and it's not under a radical, it's just all real numbers. For 38, though, you're given g of x is equal to 3 square root x squared minus 25 plus 4. You have that x squared minus 25 under the radical. So you're going to, since you do have a radical and x is under it, you're going to take the expression under the radical and set it to be greater than or equal to 0. So you're going to take the x squared minus 25, set it greater than or equal to 0, and then solve. If it was me, I would factor this. So I would do x minus 5 times x plus 5 is greater than or equal to 0. This would then separate to be x minus 5 is greater than or equal to 0. X plus 5 is greater than or equal to 0. Move your 5 over, add it on the one, subtract it on the other. This is leaving you with x is greater than or equal to 5, and x is greater than or equal to negative 5. Now you're probably looking at this and saying they're both greater than, how am I supposed to do this? Remember what we did earlier with this, where if you had greater than or greater than or equal to, greater or, it's an or statement. So your two lines are going to go opposite if you graph it. So if you were to graph this on your number line, the negative 5 and the 5 both get closed circles, and your lines go away from one another. So if you were to write this in interval notation, you're going from negative infinity to negative 5, including the negative 5, with a union from 5 to infinity, including the 5. For 39, you have h of x is equal to 3x plus 2 over x squared plus 7x plus 10. Now you have an x in both the numerator and the denominator of this fraction. The numerator doesn't matter. X can be anything in the numerator. In the denominator, it cannot be equal to 0 though. So you're going to take the expression that's in the denominator, which is the x squared plus 7x plus 10, and set it not equal to 0. So real quick, this should have been your domain is equal to. There we go. All right, so for this one, you're going to factor this x squared plus 7x plus 10. The 10 has factors of 2 and 5 that add up to be 7. So this is going to be x plus 2 times x plus 5 is not equal to 0. We're going to set both of these parentheses not equal to 0, and then solve them. So with the 2, subtract it from both sides. You have x is not equal to negative 2. With the 5, subtract it from both sides. You have x is not equal to negative 5. So if you were to write this in interval notation, think about it as on a number line. You have negative 5, you have negative 2. If you were to draw a number over these to go from negative infinity to positive infinity, but then take out the negative 5 and the negative 2, write your interval notation based off of this. So your domain would be going from negative infinity up to negative 5, not including the negative 5, with a union from negative 5 to negative 2, not including either of those numbers, with a union from negative 2 to positive infinity, not including the negative 2. For number 40, you have k of x is equal to 5x minus 9 over the square root of 2x squared minus 5x minus 4. You have a radical where x is underneath it, and it's in the denominator of your fraction. So you're going to take the expression that's under the radical in the denominator and set it to be greater than 0. So that's going to be the 2x squared minus 5x minus 4 is greater than 0. You do not have a greatest common factor, so multiply your a and your c. That gives you negative 8. Do you have factors of negative 8 that add up to be negative 5? No. So your a is the 2, your b is the negative 5, your c is the negative 4. Use the quadratic formula. So you're going to have x is equal to the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times negative 4 all over 2 times 2. So this gives you 5 plus or minus the square root of 25 plus 4 times 4 is 16 times 2 is 32 all over 4. From here, you'll add under the radical to give you x is equal to 5 plus or minus the square root of 25 plus 32 is 57 over 4. This, you got to remember, that's x is equal to. We weren't doing x is equal to. We were doing greater than. So if that's the case, then this is greater than 0, which means greater or same thing, opposite directions. So you're going from negative infinity up to the 5 minus the square root of 27 over 4 with a union of the 5 minus square root of 27 over 4, or sorry, plus to infinity. So remember, greater or, because if you were to graph this on a number line, you would have both of these open circles and they would be going opposite directions. The one with the negative would be on the left, the one with the positive would be on the right. So yeah, this is supposed to be a 5, not a 2. This is supposed to be 5. This is supposed to be a 5. 57, 57. But everything, okay, so yeah. All right, so for 41, we're stating all of the transformations from each function. For 41, we have f of x is equal to negative 3x, or sorry, negative 3 times x plus 2 squared plus 4. This negative that's in front of the 3 just means that we were reflecting vertically, so that's a reflection over the x-axis. Then the 3 means that we have a vertical stretch by a factor of 3. The 2 means that we're going to the left 2 units. And the 4 means we're going up 4. For 42, you have g of x is equal to 1/4 times the square root of negative 3x minus 7 minus 6. The 1/4 means that we have a vertical compression by a factor of 1/4. The negative underneath the radical means that we're reflecting horizontally, so we reflect across the y-axis. Your 3, you are taking the reciprocal of that. It is 1/3. That 1/3 is less than 1. So we are horizontally compressing by a factor of 1/3. The 7 means we're going to the right 7 units. And lastly, that minus 6 means we're going down 6 units. For number 43, we have h of x is equal to 1/6 x squared plus 2. The 1/6 inside the parentheses, take the reciprocal of that. It is 6. That 6 is larger than 1, so we are horizontally stretching by a factor of 6. Then the plus 2 just means we're going up 2 units. For 44, we have k of x is equal to 5/3 times x plus 9 squared minus 1. That 5/3 is greater than 1. So this is a vertical stretch by 5/3. The plus 9 means we're going left 9 units. And the minus 1 means we're going down 1 unit. For the next part in your review, you are finding the slope or the average rate of change between these given points. For 45, you have negative 3, 11, and 4, negative 9. Your slope formula is y2 minus y1 over x2 minus x1. So if we name the first point x1, y1, and the second point x2, y2, this is going to give us m is equal to negative 9 minus 11 over 4 minus negative 3. Your negative 9 minus 11 gives you negative 20 over 4 plus 3 is 7. So that's negative 20 over 7. 46, you have 5 minus 2, or 5 negative 2, and the negative 13, 10. So this is going to give us m is equal to 10 minus negative 2 over negative 13 minus 5. Your two negatives turn into positives, so that's 12 over negative 18. These are both divisible by 6. The 12 becomes 2. The negative 18 becomes negative 3. So it is negative 2 over 3 for your slope. For your next section, for 47 and 48, you are finding the slope from each function. With these, put them in slope-intercept form. From there, whatever's in front of the x, that's your slope. So for 47, what I do want you to do first is to change this to be 6y. So this is 6y is equal to 3x plus 2. So if that's the case, we are going to divide each side by the 6. And this just gives us y is equal to 1/2 x plus 1/3. The term in front of the x is your slope. So your slope is just 1/2. For 48, you have 8x plus 9y minus 3 is equal to 0. You want your y by itself, so you can either move the 9y over first or move the 8x and the 3 over. I'm going to move the 9y over to isolate it. So this gives us negative 9y is equal to 8x minus 3. We're going to divide each side by the negative 9. So we just have y is equal to negative 8 over 9x plus 1/3. Your slope, again, is the term in front of x. So it's just that your slope, so m, is equal to negative 8 over 9. For 49, it tells you to find the midpoint from each of the set of ordered pairs. Your midpoint, to take your midpoint, it's going to be the sum of your x values divided by 2, comma, the sum of your y values divided by 2. So for 49, you have p, which is 4, negative 6, and q, which is 2, 13. If we find our midpoint, we're going to add 4 and 2, divide that by 2. Also add negative 6 and 13, divide that by 2. So the 4 plus 2 gives us 6 over 2. The negative 6 plus 13 gives us 7 over 2. So we simplify the 6 over 2 just to be 3 and 7 over 2. For number 50, you're given p is equal to negative 8, 7, and q is 2, negative 3. So if we use our midpoint formula, again, we're going to take the sum of our x values. So that's negative 8 plus 2 over 2, comma, the sum of our y values, 7 plus negative 3 over 2. The negative 8 plus 2 is negative 6 over 2. The 7 minus 3 is 4 over 2. So this just simplifies to be negative 3, comma 2. For 51 and 52, we're finding the distance between each set of ordered pairs. For the distance formula, we have the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is going to, for 51, with our given points of p, which is 12, negative 8, and q, which is negative 6, 4, be the square root of negative 6 minus 12 squared plus 4 minus negative 8 squared. So that gives us the square root of negative 18 squared plus 12 squared. The square root of that negative 18 is going to be 324 plus the 12 squared is 144. So this gives us the square root of 468. That 468 is divisible by 4, I think, 4. goes into 4 one time, 4 goes into 6 one time with 2 left over, so 4 goes into 28 7 times. The 117, this is 2 and 2. This is divisible by 3. 3 goes into 11 3 times with 2 left over. 3 goes into 27 9 times. So this is 3 and 13. Your 3's pair up, your 2's pair up, so this is equal to 6 square root 13. For 52, you have the ordered pairs 1 3 and 7 9. So if we plug these values into our distance formula, we're going to have the square root of 7 minus 1 squared plus 9 minus 3 squared. Your 7 minus 1 is 6 squared, plus the 9 minus 3 is 6 squared. So that's the square root of 36 plus 36, which is the square root of 72. The 72 is 8 times 9. 8 is 2 and 4. 4 is 2 and 2. 9 is 3 and 3. So 2 2's pair up, 2 3's pair up. That's going to be 2 times 3 times the square root of 2, which is just 6 square root 2. For 53 and 54, you're finding the x and y intercepts from each. To find your x-intercept, you're going to plug in 0 for y. To find the y-intercept, you're going to plug in 0 for x. So for 53, they give you 4x plus 5y is equal to 16. If we first find our x-intercept, we're going to plug in the 0 for y, so it's going to be 4x plus 5 times 0 is equal to 16. The 5 times 0 cancels, so you have 4x is equal to 16. Divide each side by the 4, and you get that x is 4. This is not your answer for your x-intercept. Your answer for your x-intercept is an ordered pair, which is 4, 0. For your y-intercept, we're going to plug in 0 for x. So it's going to give us 4 times 0 plus 5y is equal to 16. The 4 times 0 cancels. So it's just 5y is equal to 16. So we divide each side by the 5. And you get that y is 16 over 5. So again, that's not your y-intercept. Your y-intercept is 0, 16 over 5. We're going to do the same exact thing for 54. For 54, we have negative 6x minus 3y is equal to 24. For this one, to find your x-intercept, again, plug in 0 for y. It's going to give you negative 6x minus 3 times 0 is equal to 24. The negative 3 times 0 cancels out, so you're working with negative 6x is equal to 24. Divide each side by the negative 6, and you have that x is negative 4. So the x-intercept is negative 4, 0. Your y-intercept, you're going to find your y-intercept by plugging in 0 for x. So it's going to be negative 6 times 0 minus 3y is equal to 24. Your negative 6 times 0 cancels. So that's negative 3y is equal to 24. Divide each side by the negative 3. And you get that y is equal to negative 8. So again, that's the ordered pair, 0, negative 8. For 55 and 56, you are finding the equation of the line that's parallel to the given function with the given ordered pair. For 55, you're given 3y is equal to 6x plus 9 with the ordered pair negative 2, 3. Parallel lines have slopes that are the same. So if we find the slope from this, we're going to just divide each side by the 3 to put this in slope-intercept form. So it's y is equal to 2x plus 3. Your slope of your parallel line is 2. So you're going to use that with your point slope formula. So y minus y1 is equal to m times x minus x1 with the ordered pair and the slope. Plug it in, then solve for y. This is going to give you y minus 3 is equal to 2 times x minus negative 2. The double negatives turn into positives. So this is y minus 3 is equal to 2 times x plus 2. We're going to distribute the 2 into the x plus 2 to get y minus 3 is equal to 2x plus 4. And then we're going to add the 3 over to get y by itself and put this in slope-intercept form. So this is just y is equal to 2x plus 7. For 56, you have negative 4x minus 8y is equal to 16 with the ordered pair 1, negative 6. For this one, you're going to solve this equation for y. So add your 4x to both sides. This gives you negative 8y is equal to 4x plus 16. We divide each side by the negative 8. Remember, each term on the right side gets divided by that negative 8. So that gives you y is equal to negative 1/2 x minus 2. Your slope here for the parallel line is negative 1/2. Use that and the ordered pair 1, negative 6, put it into point slope form. So that's y minus y1, which is negative 6, is equal to negative 1/2 times x minus 1. You can distribute that negative 1/2 and take care of those double negatives. So this gives you y plus 6 is equal to negative 1/2 x plus 1/2. When you move that 6 over, it has to be a fraction as something over 2. So subtract your 6 from each side. It's also 12 over 2. So that gives you a fraction that you can add or subtract with the 1/2. You're going to have y is equal to negative 1/2 x minus 11 over 2. For 57 and 58, we're writing the equation of the line that's perpendicular to the given line and it goes to the given point. With these, perpendicular slopes are opposites and reciprocals. So perpendicular slope, opposite, reciprocal. So flip the fraction, change the sign. So for 57, we have y is equal to 3/4 x plus 2. The perpendicular slope of this is going to be 4 over 3, and it's going to be negative. If it starts as positive, make it negative, and flip the fraction. From there, do the same thing you did with the questions before this. Use your y minus y1 is equal to m times x minus x1 with your new slope. This is going to give us y minus 8 is equal to negative 4/3 times x minus 9. You don't have any double negatives anywhere, so distribute in that negative 4/3. This leaves you with y minus 8 is equal to negative 4/3 x plus 4 times 3 is, or 4 times 9 is 36, divided by 3 gives you 12. From here, just move your 8 over, add it to both sides, and you have that y is equal to negative 4/3 x, this is an x, plus 20. For 58, we have negative 2x plus 5y is equal to 3. If we solve this for y, we're going to add the 2x to both sides. We have 5y is equal to 2x plus 3. Then we divide each side by the 5. And that's just y is equal to 2/5 x plus 3/5. If we find the slope of the perpendicular line, this is going to be negative 5 over 2. So we'll use that and the ordered pair 4, 9 and put it into y minus 9 is equal to negative 5 over 2 times x minus 4. We're going to distribute in that negative 5 over 2 to give us y minus 9 is equal to negative 5 over 2x plus 10. The 10 I got from simplifying the 2 and the 4 first, which gives us negative 5 times negative 2. So that's positive 10. From here, we're just going to move the 9 over by adding it to both sides. And it gives us y is equal to negative 5 over 2x plus 19. Your next question that we're going over deals with your rational root theorem and finding the zeros. Remember with these, take your constant, find the factors of your constant, use those with synthetic division. Whichever one gives you a 0 in your remainder is one of your zeros or one of your solutions. So if you look at this, your constant there is 12. Your factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. If we try 2 to begin with, you have 1, negative 2, negative 7, 8, and 12. The 1 drops down. 1 times 2 is 2, plus the negative 2 is 0, times 2 is 0, plus the negative 7 is negative 7, plus the 2 is negative 14, plus the 8 is 6. 6 times 2 is, negative 6, times 2 is negative 12, so that gives us 0. So that 2 is a solution. From here, we are going to set up a new polynomial with this negative 6, 7, and 1. The 0 would be your remainder, so the 6 is your constant. The negative 7 gets an x, 0 gets an x squared, and the 1 gets an x cubed. So this is going to leave us with x cubed minus 7x minus 6 is equal to 0. We're going to do the same thing with this since we cannot factor this. You have no factors of negative 6 that add up to be negative 7, plus you have an x cubed there, so there's no way to factor it. Do the same method that you just did with this. Your factors of negative 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. If we try negative 1, we're going to do negative 1 with 1, 0, negative 7, and negative 6. 1 drops down. 1 times negative 1 is negative 1. 0 minus 1 is negative 1. Times negative 1 is positive 1. Plus negative 7 is negative 6. Times negative 1 is positive 6. Plus negative 6 is 0. So this is also a solution for negative 1. Your remainder would be 0. Your 6 would be your constant. Your negative 1 would get an x. Your positive 1 gets an x squared. So this gives us x squared minus x minus 6 is equal to 0. This one we can factor, so we're going to factor this one. Your factors of negative 6 that add up to be negative 1 are 2 and negative 3. So this factors to be x plus 2 times x minus 3 is equal to 0. We have x plus 2 is equal to 0 and x minus 3 is equal to 0. We're going to move the 2 over, subtract it from each side. So x is negative 2. Move the 3 over, add it to both sides. X is equal to 3. So you have 4 solutions here. You have 2, you have negative 1, negative 2, and positive 3. So all 4 of these are solutions. We are going to skip 61 and 60 because both of those do not factor out correctly and they do not work the right way. So skip those. We're going to move on to 62, which is long division. With your long division, whatever's on the bottom of your fraction goes on the outside, up top goes inside. So for 62, you have x squared minus 5x plus 2 over x minus 3. The x minus 3 is going to go on the outside. On the inside, you'll have the x squared minus 5x plus 2. Remember, if you're missing a place value or a power term, plug in that plus 0 to the x to the power of whatever that you're missing. Ask yourself, x times what is x squared? That's x. So x times x is x squared. X times negative 3 is negative 3x. You will subtract these or add the opposites. So those x squared cancel. The negative 5x plus 3x is negative 2x. And we drop the 2 down. From here, the x times what is negative 2x? That's negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. We are going to subtract or add the opposites. So the 2x's cancel. 2 minus 6 is -4. That -4 is your remainder. So this gives you x minus 2 plus -4 over x minus 3. Remember, your remainder is always whatever you divided by. So it's whatever was on the outside of your division house. For 63, we have x to the 4th power minus 8x squared plus 2x plus 7 all over x plus 5. So with this one, we're going to put the x plus 5 on the outside. On the inside, you're going to have x to the 4th power. You're missing an x cubed, so you're going to plug in as plus 0x cubed minus 8x squared plus 2x plus 7. Your x times what is x to the 4th power? That's x cubed. So we multiply the x cubed times x, that's x to the 4th. X cubed times 5 is 5x cubed. We are going to subtract or add the opposites. The x to the 4th powers cancel out. We have -5x cubed. We drop down that -8x squared. So x times -5x squared is -5x cubed. The -5x squared times 5 is going to be a -25x squared. Subtract or add the opposites. Your 5x cubed cancel. The -8x squared plus 25x squared gives us 17x squared. We drop down the 2x. We then ask ourselves, x times what is 17x squared? That's going to be 17x. So 17x times x is 17x squared. 17x times times 5 gives us 85x. So we are going to subtract these, or again, add the opposites. So this is leaving us with a -83x. We drop down the 7. The x times -83 is -83x. The -83 times 5 gives us 415. We are going to subtract, or again, add the opposites. 83's cancel. The -415 plus 7. So this should have been a plus sign instead of a negative. The one originally was -415 because a negative times a positive is a negative. So we add these, and that gives us 422. So that is our remainder, which means our answer is x to the 3rd power minus 5x squared plus 17x minus 83 plus 422 over x plus 5. For 64, we have 4x cubed plus 2x squared minus 2x plus 3 all over 2x plus 1. For this one, the 2x plus 1 is going to go on the outside. Then you have the 4x cubed plus 2x squared minus 2x minus 3 on the inside. The 2x times what is 4x cubed? That's 2x squared. That's going to give us 4x cubed plus 2x squared. You subtract these or add the opposites. They both cancel. You're not only going to bring down the -2x, but you're also bringing down the -3 because you need two terms to work with. From here, the 2x times what is -2x? It's -1. So that's just going to give us a -2x minus 1 underneath. And then we subtract or add the opposites. Those 2x's cancel. -3 plus 1 is -2. So this gives us 2x squared minus 1 plus -2 over 2x plus 1. For the next section of questions, we're just using synthetic division to divide. For 65, we have 3x squared plus x over x plus 1. That x plus 1, set it equal to 0. Move the 1 over. That means that x is equal to negative 1. That's the number that's going to go in your box. To the right of your box, you're going to have 3, 1, and 0 because you do not have a constant. That 3 drops down. 3 times negative 1 is negative 3, plus 1 is negative 2, times negative 1 is 2, plus 0 is 2. So your remainder is the 2, your constant is the negative 2, the 3 gets an x. So this is 3x minus 2 plus 2 over x plus 1. For 66, you have 2x squared minus 5x plus 3 over x minus 3. So once again, we're going to set that x minus 3 equal to 0. Add your 3 over. That gives us that x is equal to 3. The 3 is going to go in our box. We have 2, negative 5, and 3 on the other side. 2 drops down. 2 times 3 is 6, plus the negative 5 gives us 1. 1 times 3 is 3, plus 3 is 6. So that gives us 2x plus 1x, or plus 1, sorry, plus 6 over x minus 3. For 67, you have x to the 5th power plus 3x cubed minus 6 all over x minus 2. So that x minus 2 gets that equal to 0. Move your 2 over, add it to both sides. You have that x is equal to 2. So your 2 goes in your box. On the right of that, you're going to have 1, 0, 3, 0, 0, negative 6. You're missing your x to the 4th power, your x squared, and your x. So your 1 drops down. 1 times 2 is 2, plus 0 is 2. 2 times 2 is 4, plus 3 is 7. 7 times 2 is 14, plus 0 is 14. Times 2 is 28, plus 0 is 28. Times 2 is 56, plus negative 6 is 50. So this means that you are going to have x to the 4th power plus 2x cubed plus 7x squared plus 14x plus 28 plus 50 all over x minus 2. For 68 and 69, we are finding the zeros and stating the multiplicity. For 68, it is factored for us. So we have x cubed times x plus 2 times x minus 3 cubed. That x cubed means that we have x is equal to 0 3 times. Your x plus 2 is meaning that we have x is equal to negative 2 1 time. And then the x minus 3 cubed means that we have x is equal to positive 3 3 times. For 69, we have p of x is equal to x to the 5th power plus x to the 4th power minus 8x cubed minus 12x squared. What I'm going to do first is factor out the x squared because that's my greatest common factor. This gives me x squared times x cubed plus x squared minus 8x minus 12. This is all equal to 0. So that that x squared means that x is equal to 0 twice. From here, you got to find the factors of that negative 12 that you can use in your synthetic division to give you 0 as a remainder. Your factors of that negative 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. If we use negative 2, negative 2 is going to go in your box. You're going to have 1, 1, negative 8, negative 12. This is going to give us a 1 times negative 2 is negative 2, plus the 1 is negative 1, times negative 2 is positive 2, plus the negative 8 gives us negative 6, times the negative 2 is positive 12, plus the negative 12 is 0. So then we have x squared minus x minus 6 is equal to 0. Your factors of negative 6 are 2 and negative 3 that add up to be negative 1. So this is going to factor to be x plus 2 times x minus 3 is equal to 0. If we set each of these equal to 0 and solve them, we are going to be left with x is equal to negative 2 and x is equal to 3. So you have the x is equal to 0 twice. You have the negative 2, you have the negative 2, and you have the 3. So you have a multiplicity of 2 at x is equal to negative 2 and x is equal to 0, and you also have that x is equal to 3. So you can say x is equal to negative 2 times, and then x is equal to 3. So you can give these that are on the left as your answers. For 70 and 71, you are using your remainder theorem to find p of something or q of something. For 70, we are given 2x cubed minus 9x squared minus 7x plus 13, and we're told to find p of 5. So our 5 is going to go in our box. On the right of that, we're going to have 2, negative 9, negative 7, and 13. Your 2 drops down, times 5 is 10, plus the negative 9 is 1, times 5 is 5, plus the negative 7 gives us negative 2, times 5 is negative 10, plus the 13 is 3. So your p of 5 is 3. For 71, you have q of x is equal to 4x to the 5th power plus 3x to the 4th power minus 6x squared plus 4, and you're finding q of negative 2. Your negative 2 is going to go in your box. To the right of that, you're going to have 4, 3, 0, negative 6, 0, and 4. Remember, place in a 0 for any power that you're missing. You're missing the x cubed, you're missing the x, so zeros go in for those. The 4 drops down. 4 times negative 2 is negative 8, plus 3 is negative 5, times negative 2 is 10, plus 0 is 10, times negative 2 is negative 20, plus negative 6 gives us negative 26, times negative 2 is 52, plus 0 is 52, times negative 2 is negative 104, plus 4 is negative 100. Your remainder is your answer, so p of negative 2 is equal to negative 100. For number 72 and 73, we are telling if the binomial that's given to us is a factor. Use your remainder theorem in order to do this. Solve the binomial for x. That number goes in your box. If you get 0 as a remainder, it's a factor. So for 72, we're given x plus 4, so that means that x is equal to negative 4. That's going to go in your box. On the right of that, you're going to have 1, 4, negative 7, negative 23, positive 23, and 12. So your 1 is going to drop down. 1 times negative 4 is negative 4. Add that with the 4, that's 0. Your 0 times the negative 4 is 0. Plus the negative 7 is negative 7, times negative 4 gives us 28, plus the negative 23 is 5. 5 times negative 4, that gives you negative 20. The 23 minus 20 is 3. 3 times negative 4 is negative 12. That gives you 0. Your remainder is 0. That means that x plus 4 is a factor. For 73, you have q of x is equal to 2x to the 4th power plus x cubed minus 5x squared minus 6x plus 4. You're given 2x minus 1. If you set that equal to 0 and solve, you get that x is equal to 1/2. So the 1/2 is going to go in your box. To the right of that, you're going to have 2, 1, negative 5, negative 6, and 4. Your 2 drops down. times 1/2 is 1, plus the 1 is 2, times the 1/2 again is the 1, plus the -5 is -4, times the 1/2 is -2, plus the -6 is -8, times the 1/2 is -4, plus the 4 is 0. Your remainder for this one is 0, so the 2x minus 1 is a factor for this one as well. For 74 through 76, you're asked to find the vertex. Remember with these, your h is your x value. It's equal to -b over 2a. Your y is k, and that's equal to c minus b squared over 4a. So for 74, you have f of x is equal to 3x squared plus 4x minus 2. Your a is 3, your b is 4, and your c is -2. So your h is going to be the opposite of 4 over 2 times 3, which is -4 over 6, which simplifies to be -2 over 3. Your k is c, which is -2, minus b squared, so 4 squared is 16, over 4 times a, which is 4 times 3, that's 12. That's going to equal -2 minus the 16 and the 12 are divisible by 4, so that's 4 over 3. The -2 can turn into something over 3, so that's going to be -6 over 3 minus 4 over 3, which is -10 over 3. So if your h is -2 thirds, and your k is -10 thirds, the ordered pair, -2 thirds, comma -10 thirds, is your vertex. For 75, you're given g of x is equal to -6x squared minus 2x plus 1. Your a is -6, b is -2, c is 1. So again, to find your h, that's going to be the opposite of -2 over 2 times -6. So 2 negatives turn into positives. That's 2 over -12, which is -1 over 6. Your k, you have c, which is 1, minus b squared, so 4 over 4 times a, 4 times -6 is -24. Double negatives turn into positives. The 4 over 24 simplifies to be 1 plus 1 over 6. That 1 is 6 over 6 plus 1 over 6 gives us 7 over 6. So the ordered pair of -1/6, comma 7/6 is your vertex. For 76, you have h of x is equal to -x squared plus 7x plus 3. Your a is -1, b is 7, c is 3. So to find h, you're going to do -7 over 2 times -1, which is going to be positive 7 over 2. Your k, you're going to have 3 minus b squared, so 7 squared is 49, over 4 times -1 is -4. Double negatives turn into positives. The 3 turns into 12 over 4 to be like term or like denominator. And you add. The 12 plus 49 gives us 61 over 4. So your ordered pair that is your vertex is 7 over 2, comma 61 over 4. For 77 through 83, we are using f of x is equal to 3x squared plus 1, g of x is equal to 4x minus 2, and h of x is equal to x squared plus 1 over x minus 3. For 77, we're finding f plus g of x. So we're going to take f of x and add it with g of x. So that just means we're going to do 3x squared plus 1 plus 4x minus 2. Get rid of your parentheses, combine like terms. Your only like terms here are the 1 and the -2, so this gives you 3x squared plus 4x minus 1. For 78, you have f minus g of x. So again, we're doing f of x minus g of x. Your f of x is the 3x squared plus 1 minus your g of x, which is 4x minus 2. Distribute the negative into the second set of parentheses. You have 3x squared plus 1 minus 4x plus 2. Again, your only like terms here are the 1 and the 2. So that's going to give you 3x squared minus 4x plus 3. For 79, we're doing f times g of x. So that's f of x times g of x. Oops. So we're just going to multiply the 2. So we're going to do 3x squared plus 1 times 4x minus 2. FOIL them out. 3x squared times 4x is 12x cubed. 3x squared times negative 2 is negative 6x squared. 1 times 4x is 4x, and 1 times negative 2 is negative 2. You do not have any like terms, so those are your answers, or that is your answer. For 80, you have f plus h of 2. So you're doing f of 2 plus h of 2. We said f of x is the 3x squared plus 1. So if you plug in the 2 there, the 2 squared is 4 times 3 is 12 plus 1 is 13. The h of 2, plug it into h of x, the x squared plus 1 over x minus 3. 2 squared is 4 plus 1 gives us 5 over 2 minus 3 is negative 1. So that's 13 minus 5, which is 8. For 81, you have g minus f of negative 1. So this is g of negative 1 minus f of negative 1. G of negative 1, you're going to have 4 times negative 1, which is negative 4 minus 2. That's negative 6. Minus f of negative 1. Negative 1 squared is 1 times 3 is 3 plus 1 is 4. So negative 6 minus 4 is negative 10. For 82, f of g of x, you're taking g of x, plugging it in for x and f of x. So g of x is the 4x minus 2. The f of x is 3 times that. Oops. So we are going to be foiling out the 4x minus 2 first. So this is going to give us 3 times 16x squared plus 16x, or sorry, minus 16x plus 4 plus 1. I just used the perfect square trinomial formula. From here, distribute in the 3. So that's 48x squared minus 48x plus 12 plus 1. Combine your like terms. That's 48x squared minus 48x plus 13. For 83, we have h of f of x. So we're plugging f of x in for h of x. So this is like saying h of 3x squared plus 1. So h of x is the x squared. So that's 3x squared plus 1 squared plus 1 over x minus 3. So that's 3x squared plus 1 minus 3. Foil out that 3x squared plus 1 squared. That gives you 9x to the 4th power plus 6x squared plus 1 all over, you combine these, that's 3x squared minus 2, which simplifies further to be 9x to the 4th power plus 6x squared plus 2 all over 3x squared minus 2. With 84 and 85, you're finding the polynomial with the given zeros. Remember with these, turn them into binomials and then FOIL them. So this is going to give you, for 84, x plus 2, x minus 3, 2x plus 1, and 4x minus 3. Then FOIL it all out. You're going to have x squared minus x minus 6 times 8x squared. The 2x times negative 3 is negative 6x plus 4x is negative 2x minus 3. and then just distribute everything out. So from here, we're just going to multiply it out. So x squared times 8x squared is 8x to the 4th power. X squared times negative 2x is negative 2x cubed. X squared times negative 3 is negative 3x squared. Then the negative x times 8x squared is negative 8x cubed. Negative x times negative 2x is positive 2x squared. Negative x times negative 3 is positive 3x. Then the negative 6 times 8x is negative 48x squared. Then the negative 6 times negative 2 is positive 12. Keep the x. Negative 6 times negative 3, positive 18. So from here, we're just going to combine like terms. We have 8x to the 4th power minus 10x cubed minus 48. Negative 48 plus 2 is negative 46, plus 3 is negative 49x squared. Then 12x plus 3x is 15x plus 18. For number 85, we have x is equal to 1, which is going to give us x minus 1. X is equal to 0, which is just x. Then x is equal to negative 6, which gives us x plus 6. And x is equal to 9, which gives us x minus 9. So we distribute in the x to give us x squared minus x. Then we have x squared minus 3x minus 54 when we FOIL out the x plus 6 times x minus 9. So we're going to multiply in this x squared. This gives us x to the 4th power minus 3x cubed minus 54x squared. Then do the same with the negative x minus x cubed plus 3x squared plus 54x. Combine your like terms. So that's x to the 4th power minus 4x cubed minus 51x squared plus 54x.